All right, welcome back to AP Physics 1, Unit 1 Kinematics. So this is the last video in this unit. What we're now going to do is everything we talked about leading up into this point was one-dimensional motion. Now we're going to look at it in terms of two-dimensional motion. So what happens now when we travel in the horizontal and vertical motions? Okay, so vectors can be mathematically modeled as the resultant of two perpendicular components. So if you look at the picture here with the resultant vector, I can take that vector and turn it into components, right, that are perpendicular. It'll have a horizontal component and it'll have a vertical component. We can put that together. We can figure out the magnitude of that vector by simply doing Pythagorean theorem, because if you look at it, all we've done is we created a right triangle. We can also take that resultant vector and split it apart, okay, which is what we call resolving into components by using trig functions. Now, in physics, we like to measure angles from the horizontal. So what that does is it always puts our x component, right, as cosine and our y component as sine. There will be cases in which those two functions will flip, because we'll look at a vertical component or a vertical angle, not a horizontal angle. But if r has a magnitude of, or excuse me, the result has a magnitude of r, all I'm going to do is multiply r cosine theta and r sine theta. Now, something to note, theta has, your calculator does have to be in degrees. Do not put it in radians. So if you go from your math to your physics class, make sure you're changing it to degrees, because in physics, we work in degrees, not radians. So in fact, when we get into units 5 and 6, we'll use radians as a measure like meters, as opposed to it being, like this measure of an angular displacement. All right. So motion in two dimensions. So what happens is motion in two dimensions, we can analyze using one-dimensional kinematic relationships that is separated into the components. So what happens is you have a horizontal component and you have a vertical component. So all those equations that we talked about a couple videos ago with the representing motion in equations, they get turned into an x side and a y side, the way it works out. All right. And so projectile motion is the special case of two-dimensional motion that has zero acceleration in the horizontal dimension and a constant non-zero acceleration in the vertical dimension. So that constant non-zero acceleration, well, that's that 9.8 number we talked about. If it is a free response question, they will want you to use this number. If it is a multiple choice question, you will probably use 10. So all those equations, those cake equations, we can rewrite using this fact. And we can say, okay, we take that quadratic x equals xo plus vot plus 1/2 at squared. We're going to take that equation, write it in the x direction of projectile motion. And something to note, that the only thing that shows up, I almost wrote the wrong part of the equation, is voxt. Because the acceleration piece drops out, you start at your x position will start at 0, and so the only thing left is voxt. Now, if you write the other equation, v equals vo plus at, in the x direction, you just simply get v equals vox, right? Vx equals vox. So this is our horizontal direction. Now, if you go to the vertical direction, this is where you get a little bit more to it, because our acceleration is negative 9.8. And so you end up with y equals voyt minus, in fact, if I do plug in a as 9.8, you end up with 4.9 t squared. And then for your y component of the velocity, you end up with vy equals voy minus 9.8 t. All right, so let's look at an example problem using these ideas, these concepts. So when you do projectile motion, the first thing you'll want to do is split the initial velocity into components. So I want to find Vx and Vy. Sorry, this should be subscript zeros too. So you got a ball thrown up with an initial speed of 20 meters per second at an angle of 60 degrees to the ground. If the air resistance is negligible, how high does the ball reach? And then what is the velocity of the ball as it hits the ground? Okay. So Vox equals Vo cosine theta, Voy equals Vo sine theta. And so you would do 20 cosine 60, 20 sine 60. If you've done pre-calc, you will find that these are this is a special angle. So this is 10 meters per second. And then this will be 20 sine 60 is going to be 17.3 meters per second. Okay. And so what we do now is we just simply write those equations with our new numbers, right? So x equals 10t, y equals 17.3t minus 4.9t squared. So all I did was plug in my velocities. Now, to figure out how high the ball reaches, the way you think about it is if this is the path of the ball, right, this is the point we're looking for. Well, in math, that is the vertex. And to find the time to get there, you would say x equals, sorry, I kind of cramming myself up here. So we'd set x equals, right, in this case, we'll write it, right, as math. So x equals negative b over 2a. Well, here's your b, here's your a. Sorry, got that written backwards. Making all kinds of math mistakes. So there's your a, there's your b. Well, and our x is not x, it's time. So I would do negative b over 2 times 4.9, which just happens to be 9.8. So 17.3 divided by 9.8. And so it tells us that it takes 1.76 seconds to get up there. And now we just plug into our equation. So y equals 17.3 times 1.76 minus 4.9 times 1.76 squared. So note that I'm not necessarily, the equations are physics, but note that I'm using math, right? I'm using math techniques I would have learned in Algebra 2 or Algebra 1, right? I'm not necessarily like saying, hey, this is that, this is a physics thing, this is a physics thing. No, I'm using math. I'm using things I already know, right? And so it's going to reach a height of 15.3 meters. So what they like to do is like say, okay, a field goal kicker kicks a football, right, from so far out with this launch angle. Do they make the field goal? How high above the crossbar is it? I've seen it used with like baseball and soccer, things like that. I've also seen it done using, firefighters trying to put out a fire. Okay, so there's different real world scenarios that they can use here. All right. So now the next thing is, what is the velocity of the ball as it hits the ground? Okay. So I'll show you the long way, but then I'll show you the trick here in a second. Okay. So we know the velocity equations. Well, we know the x component is going to be the same, right? Because no acceleration means we don't change it. All right. It's our y that's going to be different. So we're going to do VOY minus 9.8t. Okay. And so we're going to do Vy equals 17.3 minus 9.8t. Now you ask Mr. Londot, how long did it take? Well, guess what? There's some symmetry in our process. So if it took 1.76 seconds to go up, well, it takes 1.76 seconds to come down. So what we call our flight time or hang time is just 2 times that. So 2 times 1.76, so 3.52 seconds. The other thing you do is, well, again, if we want to use math, find the roots of this equation, right? You'll find one root is 0, and the other root will be 3.52 by doing some math stuff, okay? So now I'm going to plug in my 3.52, And you're going to see something very interesting. 17.3 minus 9.8 times 3.52. And you're going to find that this actually, now it's going to be a little bit different because of rounding. But remember that little trick? Well, look at the symmetry. There's symmetry, right? If I didn't round as much, right, especially with this number here, and I let it all carry out, this right here would have been a 0.3. Okay, so what happens is, what is the velocity as the ball hits the ground? Because parabolas are symmetrical, the velocity as it hits the ground is going to be what it started with. All right, so where I'm riding 20 meters per second at 60 degrees, but this is above X, right? Above horizontal. This is below horizontal, right? And how do I know that? Because my Y component ended up being negative, okay? Remember, X does not change, your Y is what changes, okay? But because of the symmetry, it's gonna hit with the same speed, just the opposite direction. All right, so that ends Unit 1 of kinematics. Looking forward to moving into Unit 2 here shortly, which is going to be forces and translational dynamics.